In this video, we're going to show how to make a resource module. So we had these, we have a lexicon full of nouns, but all of them are just records with strings, and all of these opas are just they are very redundant, and also they have this just a raw record here, which is kind of dangerous when you change the link cats. So in this video, we're going to show how to make a resource module. Okay, so let's start. Let's create a resource module. Dummy, let's call it res dummy for resource. So now it's going to be a resource module, so it has its own syntax. Let's open it here. So okay, and also let's use the syntax highlighting. Okay, now let's see if this is valid grammatically correct GF. Yes, it is. Great. So now we can actually add some operations there. So I said I wanted to move all of these lexicon building operas into the resource module. So let's start by doing that. And these as well. So now let's compile. Yes, the resource module still works, but now if we're trying to compile the old grammar, this microlang dummy, let's see what happens now. So now I'm getting a bunch of constant not found errors, so this is completely expected. So what to do? I need to open the resource here. So open res dummy in, and now microlang dummy works again. So now this is this works again. We can test even. Let's see, cc mkn tree. I'm getting a string, or I can linearize any random thing. Weight, and yeah, I get the string weight here. Great. But okay, now we actually want to do something a bit smarter. So let's see, what do we need to do here? So we wanted to add number to noun. So now this is the resource module is the place where we need to do this. So let's start. We need to have a parameter for it. So let's say param number, singular or plural. And then, so now we could do it like this. We could say that noun, mk noun constructs something that has an inflection table of number to string. And this will work as soon as we just write this table. Singular leads to string, and plural leads to string plus s. And this, now if we want to, let's see if we just compile the resource module. So this works now. But now the problem is we're operating on a very low level here. We're just calling these, we're just writing these plain records there, and there's a danger that we end up not being connected to the abstract syntax, and this is creating a lot of confusion. And if we want to change something, we have to change it in many places. Because now if we actually import the dummy grammar again, now it's complaining about a bunch of things expected a string but inferred a number to string table. So this is the, I'm going to show the standard practice how to do this thing. So we're going to give names to these types. So let's start from here. Noun. So we usually call these resource types something different than these cats in the link cats, just to not get confused. Like, so we want to change the category of this N and then also this CN and CN here. So we can create an upper of, so this is a link cat, but we want to create another type in this upper level. So we say noun is of type, we create a type. And then we write this, we define noun as this record with an inflection table from number to string. And now we can say that mkn creates a noun. And now we can say that both category N and CN have linkat of noun. So this noun which is defined here. So this is much safer than, like, otherwise if I didn't have this shorthand I would need to write this S field is of type number to string in this place and this place, and like it's easy to get, like, forget to change it in the other place when you want to change it in one place. Okay, so does this work now? Yeah, okay, so now we're getting these errors in the syntactic categories. Let's see. So here's one thing, like I could go and fix these now, but since this video is about morphology, I'm going to use this advanced technique of commenting it out and worrying about it later. So here, yes. So now I'm compiling this, and it's just warning that there is no linearization of these two functions. But I'll take care of it later, as long as we remember that that's the case. And the compiler is usually reminding us when we compile this. Okay. So now I have I've added this number as the left-hand side of the inflection table here. We can even see some linearizations. Let's see, L table animal. So now you see we're getting some results. But okay, let's try another noun. So here we see this is our morphology is not very good because it's only adding the character S and nothing else. So this is a problem. We're going to use some pattern matching to fix this. So now let's go to the mkn operation here. So yeah, we should also call this something else. Let's call it SG. So we assume that we're giving the singular form as an argument to this mkn and upper. And now we can use some pattern matching to decide whether we want this S to be just an S or something else. Like in the case of baby, the Y should change into IE. So let's start pattern matching here. We could do it here. We can use this let statement. Let plural of type string equal case SG of so if it ends in Y, what do we want to do? We want to see like, so we want to just catch this case here where it's babies. Let's show this a bit bigger. So let's just concentrate on that. So we want to see, so this is the pattern matching syntax. It's the string SG is something that ends in Y. But now we want to notice that, okay, we want it to become babies. So there is a bit of the stem that we want to retain. And so we can give it a name here. We could just call it, like, this is a variable name, it can be anything. So we can do this. So we can reuse that on the right hand side and then just add the string IES in there. So that's the first case in the pattern matching. And then, let's say, so we use the wildcard to mean any other case, like it can be any other string of characters. Then we just say SG plus S. And here we end this case matching here. And now we're ready to use this in the record that we construct. So let PL, which is a string, be this string in this expression. And here we use the string PL. And let me just align this so it makes this hopefully a bit clearer. So the table is here, like the PL string is constructed here and the table that we make is here. Let's see if resource module compiles. Yes, okay. I mean, if we had made an error, so then it would have said something like, okay, let's try. Like, let's say I forget an ending bracket here. Okay, so it's saying 2910. So, okay, actually, so this is a bit confusing, but well, it's good that you see this. So it's complaining about a syntax error at this place, and this is line 29, whereas the actual reason is that there is an ending bracket missing in here. Because now that I remove the bracket here, it thinks that, okay, this is the one that ends the table, and then it starts looking for something that ends this, like the record bracket, and then it goes all the way to here before it actually finds that, okay, no, this is syntactically incorrect. So that's why it's giving the error there. So yeah, if you get a mysterious error in some place, maybe the actual reason is the function before it. Okay, so now we can compile this again, and let's do the microlang dummy with still no linearization of these things, but we'll deal with it later. And now we can check this linearize baby noun, and now we see this works correctly.